All right, let's continue into API3, broken object property level authorization, keeping the same book-style spoken flow. I'll explain what it is, why it happens, and tie it to real-world examples where APIs leaked sensitive fields like password hashes, SSNs, or internal tokens because developers exposed more properties than intended. API3, broken object property level authorization. Sometimes the problem isn't with the object itself, but with the properties inside the object. This is what OWASP calls broken object property level authorization, OCLA. It happens when an API correctly restricts access to an object, say a user profile, but exposes too many fields about that object, including sensitive ones the caller should never see. Think of it like being allowed to look at someone's employee badge. You should see their name and job title. But if the badge also listed their salary, social security number, and personal phone number, the authorization is broken at the property level. How it happens. Modern APIs often expose rich JSON objects, and developers map database models directly to API responses. Without filtering, every field in the backend model may get serialized and returned to the client. Some of those fields might include internal attributes, security tokens, or sensitive PII. For example, a /u/profile API might return. You can see the code in our conversation history. The caller only needed the username and email, but the API leaked is admin and password hash too. Even if the password hash isn't immediately usable, attackers can attempt offline cracking. Real world case, Facebook 2019. In 2019, security researchers discovered that Facebook's APIs exposed fields not intended for general use. In one case, APIs serving third-party apps returned phone numbers and email addresses that were supposed to be private. The underlying problem wasn't broken authentication, it was excessive fields being returned in API responses, effectively bypassing privacy settings. Snapchat 2014 Find Friends bug. Snapchat's Find Friends API once allowed querying users by phone number, but the API also returned additional properties, including usernames and other metadata, without verifying whether the caller was authorized to see them. Attackers scraped millions of Snapchat usernames and phone numbers, which were later dumped publicly. Again, the problem wasn't that the API let you query objects, it was that it exposed far too much data per object. Real-world case, Financial Services API. In 2020, a fintech firm was found leaking internal access tokens in API responses. Developers had built an admin API for testing that included a debug field returning the raw OAuth access token used to process the request. In production, this field was still present. Attackers who spotted it could extract valid tokens and impersonate legitimate users, escalating the breach dramatically. Why bBOPLA persists. The root cause is often overexposure by default. Developers serialize full objects for convenience, thinking it's easier to just return everything. Or they forget to enforce field-level authorization. Just because you can see a user object doesn't mean you should see every property of that object. This is especially dangerous in GraphQL APIs, where clients can query for arbitrary fields. If sensitive properties are exposed in the schema, even if they weren't intended for normal use, attackers can request them directly. Mitigation strategies. 1. Response filtering. Always define explicit whitelists of fields to return. Never serialize database objects directly. 2. Field-level authorization. Check not just, can this user see this object, but also, can this user see this field of this object? 3. API schema audits. Regularly review your OpenAPI or GraphQL schemas to make sure no sensitive fields are accidentally exposed. 4. Test for excessive data exposure. Security testing should include validating that APIs don't return unnecessary or sensitive properties. Lab exercise lab you can try. Build a get_user/ID endpoint that serializes and returns the entire user model. Add a password hash field to the database. Query the API, you'll see the password hash included. Now refactor the endpoint to explicitly construct the response object, returning only ID, username, and email. Query again, and notice the sensitive fields are gone. This exercise shows why explicit whitelisting is safer than default serialization. The lesson here is simple. Authorization must apply at the property level, not just the object level. APIs that overexpose fields hand attackers data they never should have had. Many breaches didn't require brute force or injection. They just required reading fields the API carelessly returned. Shall I continue into API 4, unrestricted resource consumption, explaining how APIs can be abused through excessive requests, oversized payloads, or infinite queries, with cases like GitHub's 2019 outage and GraphQL deep query DOS attacks?